All right, lesson 9 in your book. It says create a bar diagram to show 3 plus 5. So like I said, you want to make the 3 first, darken that line, and then add 5 on. How would this look if you were asked to show 5 plus 3? It looked pretty much the same except 5 comes first. And then you darken the line, and then you put 3 more on. And are they equivalent? Yes, they both equal 8. With addition, the order that we add does not impact the result. And again, that's the commutative property. So how can we show a number is increased by 2? Well, if we're going to do a number is increased by 2, we just say we have a number. We're going to say n increased by 2, like that. And can you prove this using a model? So here's my model. And our equation would be n plus 2, or in our expression. And it's an expression because we don't know what it equals, and those are just called expressions. So on the next page, it says write an expression to show the sum, and remember sum is addition, and so that just means we have m plus k. And then which property can be used in 1 through 3 to show that both expressions given are equivalent? And we can demonstrate that property right here. And the reason this is true is the commutative property. And again, it is a critical standard that you're able to identify the commutative property, as well as the identities of the multiplicative identity of 1 and the addition property of 0, which is what we did on Friday. Remember, the addition property of 0 states that any number added to 0 results in the same number. And then the multiplicative identity of 1 is any number multiplied by 1 is itself. So how can we show 10 minus 6? Well, draw a bar diagram with 10 boxes in it. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then it's minus 6, and so I'm going to take off 6 of them. And that leaves the 4. And what expression would represent this model? 10 minus 6 would represent the model. And could we also do 6 minus 10? No. The commutative property only applies or works with addition and multiplication. So down here at example 5, you have start by drawing a diagram to model the subtraction. So how can we write an expression to show 3 less than? This is what I was talking about in your notes. 3 less than means we're subtracting 3, and then a number you could pick anything. So we would have m minus 3. And the way that model would look is you have this whole big thing. I say that whole thing is m, and then I'm taking 3 off, and I would just color it in, or you could put x's in it. So that's m minus 3. Right here is your expression. So your expression is that. Our next example. How would we write an expression to show the number c being subtracted from the sum of a and b? This is when you're going to start having, you need your parentheses. So how do we write an expression to show the number of c? So c being subtracted from. So that's minus C. And then the sum of, so we have the sum, which is addition, and then we have A and B. So the sum of A and B. So we're going to start with that. Sum is addition. And then it says now show C being subtracted from the sum. Well, we have the sum first, and then we subtract C. So they know it was stated to do this and then to subtract it. Write an expression to show the number C minus the sum of A and B. So C minus is C minus, then the sum is addition, A and B. So C minus the sum, A and B. So why are the parentheses necessary in this example and not the others? So if I look up here, order of operations says you add subtract from left to right. So if I didn't have the parentheses, I would still add these first and then do this one. Where down here, order of operations would require me to subtract first because it comes first in the expression. But it said we have to find the sum of this, which means this had to be done or we couldn't take C minus the sum. And so this parentheses requires us to find that sum before we do the subtraction. And so the parentheses require us to find the sum before we subtract from C. So replace the variables with numbers to see if C minus A plus B is the same as C minus A plus B. So if C equals 1, no, let's say C equals 4, A equals 1, B equals 2. So C, so that'd be 4, minus, parenthesis, A is 1, B is 2. And if I solve that, I have 4 minus 3, which gives me 1. And then over here, we have C, which is 4 minus A is 1, plus B, which is 2. So I have 4 minus 1 is 3, plus 2 is 5. So, as you can see, it definitely does not equal the same thing. So that parentheses makes sure we get the correct answer, because this is the correct one for what that sentence was telling us up here. So here are a couple examples. I'm going to have you finish it out. You're going to answer all 5 of these, and I will check them. You'll come and you'll stand at the line, and I will check them before I move you to the problem set. Make sure you're reading all of them. Each one, there is an example somewhere else in this, in your notes or in the lesson part for you to find those answers.